Hey everyone, welcome to my channel. In this video, we are going to create a computer vision game using OpenCV in Python. We will learn how to detect the balls and find out which region did it hit on the board. We will go step by step so it is easy to follow. If you would like to level up your computer vision skills, do check out our premium courses. The link is in the description. So without further ado, let's get started. So here we are in our PyCharm project, and you can see that we have called it Velcro Dart Game. And we already have the videos folder and one.png. This is the image that we will be using. But why do we have these? The reason is that some of you might not want to buy the actual Velcro dartboard. So if you want to learn the technique, then this should be enough to follow along and learn the principle of computer vision behind this project. So we will have some videos. You can see you have 3 videos here, and then we have the one.png. This is the dartboard, and behind that I have also attached a board behind it. So what we will do is that instead of using the actual webcam, which I have already set up next to me, we are going to use the videos instead, so that the ones who are at home and don't have the equipment, they can follow along as well. So this image and these videos, they will be available to download from the website. The link will be in the description below, and all you have to do is you have to sign in, and then you can download these files. Okay, so the basic idea behind this project is that we want to detect the hits of the ball, and we want to see where did it land. And based on the location of it, we are going to give it the certain points that are allocated with it. So for example, if it hits here, we are going to say 5. If it hits here, we are going to say 60. But the thing is that these are not square shapes, or they are not circular shaped. So each one of these has a different shape. So for example, you can see here, this is a polygon with 4 points. And again, we have most of these are 4 points, but they have different locations, and they don't really fit in a rectangular shape. So what we need to do is we need to check for each one of these whether the ball has hit in this space. And if it hit, for example, in this space, then we are going to say give it 60 points. If it hits, for example, at this point, we will say give it 5 points, and so on. So we need to find all the locations of these, and then we will save them, and then we will check where did the ball hit. The second thing is that this image is actually a little bit tilted. So let me exaggerate a little bit so you can see better. So for example, if you see the camera, this is the dartboard on the side, and then the camera is below the dartboard and it is facing upwards. So this is the angle of view of the camera. So we are looking from the side. So therefore, the image that was supposed to be a rectangle will now be something like this. So it will be a little bit bigger at the bottom. So here you can see this line will be bigger than this line. So I'm exaggerating it a little bit here so you can see what is happening. So instead of a perfect circle like this, we are going to get something like this. So this is what we are getting. So what we will do is we are going to collect these points. We will collect these 4 points, and we are going to warp it into this. So we will convert it into a rectangle, and then from that we are going to find all the locations of our different points, our different polygons, and based on these polygons we are going to see where did the ball hit. So this is quite a long project, so it might take a while to actually complete. I'm not sure how long this will take. So let's go ahead and get right into it, and let's see how it goes. Now the thing is, we will only need one package. So we will go to File, Settings, and we will go to the projects and the Python interpreter, and I'm using Python 3.7. Feel free to use any other version that you have, but if it doesn't work, then it's always best to come back to the stable version. For me, it is 3.7.6. So if you want to try that, you can try it with that. Okay, so let's add our library. So we are going to add CV zone, and this is the only package that we will need because it will install the OpenCV and the NumPy package that will be required at the backend that will do the actual computing. CV zone is just a wrapper to make to add a little more functionality to these libraries. Okay, so now you can see Python has been installed, OpenCV Python and NumPy has been installed as well. So that is good. Now we are going to create a main file. So let's call it main.py. And the first thing we will do is to import the computer vision library CV2. CV stands for computer vision. Then we are going to import CV zone, and then we will import NumPy as NP. Now I will later on tell you why we need all of these. And then we will import from CV zone dot color module. We are going to import color finder. So when we are detecting the ball, we are going to detect its color. So you can use other methods as well. You can even use a machine learning model that you can train to detect these different balls, and then you can detect it from that, and then the rest of the project will be the same what we do. But here we are using the color method. But if you are using the color method, you have to make sure you don't have that color in the dartboard. So for example, we are using green darts, so they are not, the green color is not present in this dartboard. So we can do that. If you have the same color, then it might be conflicting and it will cause a problem. So then you might want to refer to contours method to actually get the edges or the circle, or you might want to use a half transform to find the circle, and there are many other ways you can do that. But for this purpose, for this project, we are going to do the color finder. And the idea behind this project is not that you copy exactly what I have done. It's the idea is that you understand the basics, and from there you can create your own project. I'm pretty sure you are more creative than me, so you can embed this into your own projects and create much more better projects. So hopefully this will help you out. So we will also import pickle. Now, why do we need pickle? Well, the thing is that we are going to define all of these points and all of these polygons and their regions, and we will define their points as well. So to do this, we are going to create a new script in which we will just label this dartboard. So for labeling, we will create a new script, and we are going to save a file from that script, and we are going to import it here for that information. Now this might seem a little bit confusing at this point, but don't worry, I will explain when we come to that point. Okay, so now the first thing is that we are not using the webcam, but we still need to import the video. So we will write here cap.cv2, and the webcam and the video is pretty much the same. So video capture, if you are capture, so if you are using a webcam, you will just write 0 or 1, whatever. So you can use that, but in this case we are going to use a video. We will get it from the videos folder, and this will be video number 1. So yeah, we need to write the extension as well, .mp4. Then we are going to write while true, and we will write success and image is equals to cap.read. We are going to read each frame, and we will write cv2.wait key, and we are going to write not 0, we will write 1, and we will also do the imshow, cv2.imshow, and we are going to write here image and img. There we go. Okay, it seems that there is no configuration here. So what you can do is you can simply right click here and run main, and that will automatically solve that issue for you. Okay, there you go. So now we are getting our video. So this is actually a static video. You can say the camera, the webcam is still, and there's nothing showing in it. Video number 2 is actually with the balls hitting. So here I missed 1, and then there's 2 and 3. So they're moving really fast. So we will have to slow them down as well, so to make sure that they are 30 frames per second. So we can slow it down from here. For example, we can write 50 and it will slow down about 20 frames per second. There you go. So that is another hit. And the good thing is we have different variations where it hits, where it falls down, where it hits in the wrong place. So all that. So if we run this, it will run and then it will stop. So it will give us an error. So why did we get this error? The reason is that the video ended. So what we need to do is we need to, let's just put it as 1. So we need to keep this loop running so that when we are testing, it doesn't just quit every time. We want it to keep running. So here we are going to write frame counter plus equals 1. So we are counting how many frames have passed by, and we will check if our frame counter, actually let's just define it, otherwise it will keep giving an error. So let's just write here frame counter is equals to 0. So initially the frame count is 0. We are adding to the frame counter, and we will check if the cap dot get cv2 dot cap underscore prop underscore frame underscore count. So if it is equal to that, then we are going to write here frame counter is equals to 0, and then we will write cap dot set cv2 dot cap underscore prop underscore position underscore frames is 0. So basically what we are doing, we are saying that keep counting the frames, and we will check how many frames are actually in our video. So if we have reached the maximum frames, then we are going to set the frame back to 0. So it will reset the video. So right now it is at a very high speed. So if we run it, it will hit a few times, and there you go, it starts again. So this is what we want. We don't want it to stop and give us an error. So that is good. Now the second step is to actually warp the image. So if you remember, we need to take these points and we need to warp so that we get a completely centered image and there is no tilting of the dartboard. So how can we do that? We can go to our image. We will open it up in the Explorer. And here we are going to right click and we are going to click on edit. So this will open up in Paint. And what we are going to do is we are going to note down the values of our corner points. Now you could do this with dynamically as well, but we are not going to do that because it will just add a little more complexity. And in this case, it is not required because the camera is not moving. The camera is stationary. So we don't need to do that. So let's just look at the points. So if you look here, when I point it to the corner, you can see at the bottom left corner, it will give you the pixel value. Right now it is saying 377 and 52. So I'm going to write that down and I will say 377 and 52. That is my first point. Then we are going to look at our second point. Our second point has to be this over here, which has width and the height is 0. So 944 and 71. So we will write here 944 and 71. If you are following along with the image and the videos, then this should be exactly the same what I'm doing. So then if we go down here, it will be 261 and 624. 261 and 624. Then we will do the last one, and the last one is 1058 and 612. 1058 and 612. So these are the 4 points that we need. We are going to comment them right now. And we will actually, let's just put them in points. So we will write here points. Actually, let's give it a better name. Instead of just saying points, let's say corner points. Corner points. So our corner points are basically these values 377 and 52. Then we have another one, then we have another one, and then we have another one. So we have a list of values, and within that list there is another list that has two values, x and y. So this is the basic idea, and the order has to be exactly the same, otherwise it will not work properly when we warp the image. So if this was dynamic, we would have to sort these points and actually find which one is 0 0, which one is width height, which one is 0 height, and which one is 0 width 0. So but in this case we don't have to do that. Okay, now to warp it, what we can do is, instead of doing it all in the while loop, we can actually create a function, and we can, for example, call this get.board or get board. So let's say get board, BOARD, and we are going to send in our image to get the board, and in return we need the output image. So we will write here image, or yeah, let's call it image output is equals to this, or should we call it image board? I think it's better if we call it image board. Yeah, so get board, we are going to define this. We will write here get board, and then we will take in our image, and then we need to add our warping part. So for warping, first of all, we need two sets of points. The first point we already have, so the points 1 is equals to numpy dot float. Now we are going to use the warp perspective function and the get warp perspective transform. Now these functions, they require these values or these lists in a certain type. This type is float 32. So that's why we are using numpy to convert this list into a float 32 list. Otherwise it's not really required, but because it's a requirement of the function we are about to use, so we do have to do that. So here we will write float 32, float 32, and then we will simply give in our points. So these are our corner points, my bad. So we are going to write corner points, and this will be our first point. Then the second points will be, what exactly do you want this to be? So this point here, if you look at our image, this point here, what is the size of this? Okay, so this point here should be 0 0. This point here should be width 0. This one is height 0 height, and this one is width height. So we need to define each one of these. So we are going to write here points 2 is equals to, again, numpy dot float 32, and then inside that we are going to create our matrix like we did before, and this time we will say the first one is 0 0. Then we have the second one, the third one, and the fourth one. The second one is width and 0. The third one is height, 0 and height. And the fourth one is width and height. So this is the basic idea. But what is width? What is height? Where do we get it from? We can get it from our original image. So width and height is equals to, we are going to write here integer, and we are going to write in our values. So here we have to give in the size of the actual board. So the size of the actual board is basically 400 by 380. But this is quite small. So what we will do is we will multiply it with a factor. So this is the actual size in mm. So what we will do is we will multiply it by 1.5, and we will multiply it by 1.5. So we are keeping the aspect ratio same. We are just scaling it up. Then once we have this information, we are going to get the transformation matrix that will allow us to warp the image. Now, if you're not familiar with all of this, I highly recommend that you check out my warp perspective video, and it will give you a little more detail about this. So here we are going to write matrix is equals to cv2 dot get perspective transform, perspective transform, and then we are going to write points 1 and then points 2. Then we are going to write here that our image is equals to cv2 dot warp perspective. Perspective is basically image, and then we have our matrix, and then we have our width and the height. There you go. So this will give us the output image. Let's write here output. This is the output image, and then what we can do is we can send it out to our actual image. So we can basically out of the function we can write here image output. So that will be returned. So what is happening here is that we are creating the matrix based on this information, and using this matrix we are transforming this image that we are getting, and we are storing the output image using the width and the height that we have provided here. And if you want, you can actually draw the points, these 4 points, not these 4 points, that will allow you to see if you are getting the correct points or not. So here you can write for x in range, let's say 4, we are going to write cv2 dot circle, and then we are going to put it on our original image. We are not putting it on this, we are putting it on our original image, and then we are going to write our points. So we will write here corner points. We are going to get the x value, and then we are going to get 0. This will be the, so for example, this first value will be this. So this is the 0th element, and this is the first of it, the first element of it. So then we are going to write again the same thing, but we will get the second element, which is 1. And then we will give it a thickness, or the radius, we will give it 15. We want it to be big, and we will give it a color. Let's give it green, 255 and 0, and then we will say cv2 dot filled. So we want to fill it up. Okay, so let's go ahead and run this and see if it works. So let's run that. We are getting image is not defined. So what is not defined? Where is it? Here, image is not defined. Why is that? Okay, well, we need to do it after we read the image, not before that. Okay, so let's run that, and there you go. So here you can see these are the correct points, and if you look at, does it give, no, we didn't actually get the output, so we need to write here cv2 dot imShow, imShow, and we will write here image, let's say board, and we will write here image board. So let's run that, and there you go. So this is our image board. Now it is straight, even though this is a little bit curved, that's fine, but our image actually is straight at this point. So we have converted it from this to right, where it looks like it is dead center, it is dead straight. So this is good. Now we have warped our image. Now what we need to do is we need to save one of these images so that we can use it for color detection, and we can also use this to find the points where exactly are all of these different polygons. So we need to save 2 images. So we can write here cv2 dot im read, and we are going to give it a name. So we are going to write here image, it should be in quotations, image, and then we will give it an extension .png, and then we will write here image board. So let's run that. Flag is required to be an integer. What mistake did I do? So I am, oh sorry, not I am read, I am write, my bad. What am I doing? Okay, so when it has all three, I'm going to stop. 1, 2, 3, stop. So now I know it's a weird way to do this, but here you can see now we have the image with all three balls at the same time. So now we can go ahead and do the color detection for this image. And for the second image, we will call it image board, BOARD. So we want it when the board is completely empty. So we can stop it right now, and the board is completely empty at this point. So we can use this image to find all these polygon locations, because this is exactly what we are going to get every single time. So these are the two images that we have that we will be using on later. So let's go ahead and first of all detect the color now. So now that we have our board and we have our image, we are going to detect the color. So for the color, we don't need to create, or we don't need to use the video. Instead, we are going to use an image. And what we can do is, instead of writing this line, we are going to comment this out, and we are going to write image is equals to cv2.im read, and we are going to read in our img .png. So we will write here image.png, and let's see if that works. And there you go, it works. So we are getting our main image. We can forget about the image board because right now we are not using the actual size. So the next step would be to actually find the color. So for the color, we have already imported our color module, and we are going to use the color finder. So when we are using the color finder, what we have to do, we have to write here color finder is equals to color finder, and we need to give in the debug. So by default, the debug is false. So we are going to put it true, because we first of all need to find the color and then we can apply it. So to find the color, we will put debug as true. And then over here, once we get our image, we can remove this part for now to get the board. Actually, let's keep it because it will be annoying. Let's keep this as well. I don't want to delete it from the code. Maybe you want to use it later on, but let's just not use it for now because we are done with doing the images. I hope it did not overwrite. Oh yeah, it did overwrite. That's bad. So we can fix that later. I should have removed it before. Anyways, so what we will do now is we are going to find the color. So what we need to simply do is we will call our object that we have created, and to call it, we will simply call the update method. So here we can write that our image color and our mask is equals to color finder dot update, and we will give in our image to update. That's it. So right now it is in debug mode. That's why we don't need to tell it which color to find and which color to update because we are about to find out. So here you will see that we have a new track bar, and what we can do is we can move this track bar to change the color here. But right now we are not viewing the image color, we are just outputting the image. So we need to output cv2.imshow, and we need to write here image color, and we will write image color here. So let's run that. So this is our image color, and if I move this, you will see the color changes. So we need to find the color of this green. So we will move it until only this green is left. So we want to remove everything except this green. So we need to move it a little bit more. There you go. Now we are getting somewhere. So this is quite fine. Yeah, I think this should be fine. So we can take this as our output color. So let's stop this, and this here will print the color for us. So what we have to do is we just have to copy it and we have to paste. So what we can do is let's just run it one more time to be 100% sure, because this is a tricky part. So let's just move it a little bit. Let's say we bring it down to, let's say, 40, and this one we will bring it further to 20 something. Yeah, there you go. And this we need to move it a little bit, not too much. And yeah, I think that's good enough. So we will stop here and we will copy this. And now what we have to do is we have to go up here and we have to define this as our HSV values is equals to this. So here we will put it as false. Now we have finished the debugging. We know which color we want to update, which color we want to find. So here we will simply give in the HSV values, and now it will only detect this color. So if we run this, you can see it is giving this by default. There is no track bar detected, and this is the image that we get. So to test it out, what we can do is we can remove our IMBreed from here and we can go back to our video. So let's run that, and there you go. So let's see, there you go, we got one hit, there you go, another hit, and then another hit. So that is pretty cool. And what we can do is we can create the mask. We can show the mask out of this. So let's copy this part, and we are going to write image mask, and we will write here mask. So if we run that, this is our mask. So you will see, there you go, this is a clear hit, this is a clear hit. But the issue here is now that there are black lines in between, so we are not really getting a perfect circle. And this is a problem because when we go to detecting the contours and detecting the center point of this, it will not detect it as one ball. It will detect it as different small triangular or rectangular, whatever the shape is, 4 pieces, 3 pieces, something like that. But we need to join them together, and we need to remove these noise as well, this noise. Otherwise, it will not work properly. So what we will do is instead of just writing it down here, we are going to create another function, and we are going to call it, what should we call it? Let's call it detect, or yeah, detect color dots, let's say. So, and we are going to give in our image again, and here we will do all the processing, whatever is required. We need to reduce the noise, we need to increase the dilation, erosion, whatever is required, we will do here so that it doesn't interfere with the rest of the code. And here we can simply call in the function. So what we actually need is the mask. We don't care about the rest. What we care about is the mask. So here we are going to write mask is equals to detect color dots, and we are going to send in our image board. So this is the idea. And image color, should we keep it, should we remove it? Let's put it inside here. Okay, so this is, yeah, this is correct now. And we will return the mask. So here, oh, what did I do? Here we are going to write return mask so that we don't forget later on. And now we need to process this a little bit better so that we can get better results. Actually, the mask as well. Or yeah, let's just keep it here. Let's keep the mask here. Okay, so the first thing we are going to do, we are going to add a little bit of blur before we send the image. This will allow it to not be very sharp, and it will allow it to be less noisy. So here we will write image blur. Blur is equals to cv2 dot Gaussian blur, and we are going to give in our image, and then we will give the kernel size, let's say 7 by 7. It has to be odd numbers, and then we will give the delta value. So this should be fine, and let's just put this as our input instead of the actual image, and let's see if we see any difference. So where is the image color? There's the image color. There you go. So now you're seeing the blurriness, so that will help us with the detection with the noise as well. Okay, so now if we look at this again, you can see that we have some noise here, and we need to remove this. So one of the methods of removing noise is basically opening, and this is basically an erosion followed by dilation. So in OpenCV we have this function called open, and we are going to first of all define a kernel. Kernel is equals to np.ones, and we are going to define it by the size of 5 by 5, and then we are going to give it numpy dot unsigned integers of 8 bits. So this kernel we are going to use, so we will write here mask is equals to cv2 dot morphology x, and we are going to write here mask, and then we will write cv2 dot morph underscore open, and then we will give in our kernel. So here we will write mask. So this will remove that noise. So here we can write different values. Again, this has to be odd. So if we run this now, there you go. So this is the image color, and this is our mask without that noise. Now you can see we are only getting the balls. So you can play around with these values to increase or decrease the noise. Then even then you might have a little bit of noise here and there. If you want to remove that as well, well, you cannot remove all noise, but you can try your best. Here you can add a median blur. So here you can write mask is equals to median cv2 dot median blur, and you can write in your mask, and you can give in the intensity. So here we are giving it a high intensity. So let's see. So here now you can see the noise is reduced a lot, and now you can see only pretty much the balls. The noise is very little. So now we have reached a good point. It is it's not noisy anymore, but the issue is now that the balls, they are not looking like balls. That's the problem. They are far apart and they are different objects. Here you can see they are not joined together. So we need dilation function here to join them together. So we will write here mask is equals to cv2 dot dilate. No, the spellings are wrong. Dilate, and then we are going to write mask again, mask, and then we will give in our kernel. The kernel we are using the same. If you want to, you can change the kernel, and then we are going to give in the iteration. Iteration. What are the spellings? Iterations is equals to 2. So we are going to write it like that, and let's go ahead and try it. There you go. So there you go. Now you can see it's much better. Almost an object. We can increase the iteration again, but there is another function which is the opposite of this. It is open. The other one is close. So we can copy the kernel and this function, and instead of um, opening up, we are going to write here close, and we are going to give it a little bit harsher values so that you can see still there are gaps. We want to close it aggressively. So let's see if that works. There you go. So now it is almost close, and we are getting these blobs that we can use as the location of the ball head. So again, it is not perfect, but it is a good start, and you can keep improving with different parameters. I did not spend a lot of time on this, so if you want, you can definitely get better results than what I have received here or what I have got here. So you can definitely try to change them. Okay, so now that we have our mask, what we can do is we can find its location. So we need to find the contour, and we need to draw the contour around it. So let's write it. Where is it? So this is the dart color, and then after that we are going to find the contour. So we'll write here CV zone dot find contours, and we will find from the image board, and we want to draw on the image board, and we want to find the contour from the mask, and then we have a minimum value of 3500. So minimum area, you can play around with this area as well, and then we want to draw it. So we will keep it like that, and let's see how it works out. So we are going to return it to image contours, and then we will write here contour found. So this will have all the contours and the information of their location, their size, their bounding box and whatnot. And this is the image with the contours drawn. So we are going to output that as well. So we will write here image contours, and we will write here image contours. So let's run that, and this is image contours. So as soon as we get something, there you go, you saw that blue, there you go, perfect, perfect. Oh, this is flickering, but still not bad. So maybe we can play around with the values a little bit to get better results. So this is the basic idea. Here you can see now we are getting the center points, and we are pretty much getting the bounding box. So you can see the bounding box is quite accurate, even though we are getting weird blobs, but still the bounding box is pretty much around the circle. So that's a good sign. So that is good. Let's try to change the value here a little bit. So what should we change? Maybe the iteration here. Let's dilate it a little bit more. Yeah, that worked. So we just had to dilate a little bit more. What if we do it 4? Is it going to get better? Let's try that. Yeah, seems to have gotten better. Perfect. So the overall area and the center point seems quite accurate. So that's good. We can try it with the second video as well. So video 1, no, video 1 does not have anything. Video 3 and video 2 have the ball hits. There you go. There you go. And there you go. Perfect. So again, try to play with these values. Here you can see you are getting some noise. So maybe to reduce the noise, we need to increase the kernel for this, for the open. Let's make it 7, and 7. Perfect. So now it's much better. The noise is gone. And the center region is, I would say it's quite good. Okay, good. So this is basically the idea of how you can find these contours. Now what we need to do is we need to first of all save when it hits, and secondly we need to check where did it hit, and based on that location we are going to either increase the points or not increase the points, and we are going to color that area in which we have found the hit. So that is our next step. So how exactly can we do that? Now the first thing is that we need to find the hits and we need to save those hits. So what we will do is whenever there is a hit, whenever there is a contour detected, we are going to wait for 5 iterations or 5 frames before we count it as a hit, because sometimes it is in the air, it is reaching the board, and we don't want to detect that as a hit. We want it to be on the board for a little bit, for example, for a few milliseconds before we detect it as a hit. Because sometimes when we throw the ball, it will hit and it will fall down. So we don't want to accept that as a hit as well. So this will actually fix that problem. So what we will do is we will say that if contour found, if it has anything inside, what we will do is we will add a counter. So we will write here count hit is equals to 0, and then here we are going to write count hit. What did I write? Count hit plus equals 1. So we are going to count whenever there's a contour found, we are going to keep counting it, and we will say if count hit is equals to 5, let's say. So if for 5 consecutive frames we are getting the confound, then we are going to detect it as a hit. And how do we detect it as a hit? We are going to save this image and its location in a list so that we can display it continuously. So what we will do is we will save this in a list. So we will call it, what should we call it? Image list balls detected. I know it's long, but at least we can tell what it means. So here what we will do, we will append. So dot append, and we will append the mask. So whatever mask we got, we are going to append it here. So what this will do is this will give us a black and white image of where did the ball hit. Now what we are about to do is something weird, and we will save the contour information as well later on. But for now, what we are going to do is we are going to print here, let's say hit detected. Okay, so whenever it saves, we are going to write here hit detected, and I will tell you why did we store these images. So hit detected 1, it didn't say hit detected again. Why did that happen? So 1 hit, 2nd hit, and 3rd hit. Okay, I know why, because we did not put it as 0. Count hit is equals to 0. So if we run that again, then hit detected, hit detected, hit detected. So it's doing more than that. Okay, so that's not good. When the count hit is 5, then it should be 0. Oh yeah, I forgot. So it will keep saying hit detected, because if you look at this image, now it already has the previous hit and the new hit. So whenever it looks at the images, it is finding this contour, this and this. So whenever we detect a hit, let me pause this. Okay, now it's paused. So whenever we detect a hit, what we need to do is we need to remove the contours from our previous hit, so that if we detect any new contour, it just finds the new one and not the old ones. So if this is my first hit, I will save this image, and then when the new hit comes, I will subtract the new image from the old one so that I don't get the previous contour detected. So this might be a little bit difficult to understand. So what I will do is I will write it down here to explain. So for example, this is my first hit and this is where it hits. And then for my second hit, this is where it hits, this point here. But my first hit is already present at that point. So when I am sending it to find the contours, it will find both the contours, this one and this one. But we don't want that. We just want to find the new one. So how do we do that? We subtract these two images. So if you subtract these images, the resultant image will be this. So this point here will cancel out. So this is what we will do each time. So for example, our first image, let's say we find the hit here. So we will store it in a list. We will say our first hit is here. Then we get the second hit. The second hit is at this point, and now our two contours are at this point. So we will subtract it with this. And then our resultant image will be this. Now we will save this image in our list. So this will be our second hit. And then we get a third hit. The third hit is basically at this point. So we will have the other two hits as well in the webcam image because they are already on the dartboard. So what we will do now is we are going to subtract this image from this and from this. So when we subtract it from both of them, then we will find this as our new contour. And then we will check our new location and we will detect it as a new hit. I hope that is clear. So that is what we are going to do. So let's go ahead and try that out. So right now what we are doing, we are storing that image in this image list balls detected. So now what we need to do is we need to remove the previous detections. So here we are going to write remove previous detections. So here we are going to write for for image in image list balls detected, we are going to loop through all the images that we have detected, and then we are simply going to do mask is equals to mask minus our original image. So this is the new mask minus our old mask, our image that we are getting from this, which was the old mask. So this is the basic idea, and what we can do is we can display each one of these in a separate image. If you want to see, we can write here X, and then we can write here enumerate, and we can output each of these. So we can write here cv2.imshow, and we will write string and X. The reason we are enumerating because we need a different name for each image. So we are putting a dynamic name for each image, and then we can simply write mask. Why am I writing the spelling of mask wrong every single time? I don't know. Okay, so let's see. So this is, oh my god, so it is doing a lot of times. That's not good. So we need to do it one time and then we need to stop. So I will hold it. There you go. Oh, I can't. That's way too much. How can we stop it? Maybe if I just remove this frame counter, maybe it will stop. No, it didn't stop. Why didn't it stop? Or let's just put a big delay between each of the frames so that it is easier to see what is happening. So let's put a 500 millisecond delay. So this will take a long time, but we will be able to see. No, that's too much. Let's put it at 100. So when we get the first hit, this is our first image, second image, third image. Oh my god, so that's not good. So we are getting a lot of images right away, which is not good. Okay, so how can we make sure that it is working properly or not? What we can do is we can put this back to 1 first of all. Then we will put this back to continuous. And then, by the way, this should be after the contour find should be after removing the previous detections. Okay, let's run this now. There you go. 1, this is 0, 1, this is another one, and then there is a third one. There you go. So each of these is at a different location. So right now we need to check how many hits did we detect. So the number of hits are lower than before. So let's see the first hit, the second hit, the third hit. Perfect. So now our hits are proper. Now it's repeating the video again and again. That's why the hits are repeating. But now we are able to detect each hit individually because we are removing the previous hit and then we are only looking at the new hit. So now we can perfectly tell how many hits that we detected. So this is all good, but now is the tricky part where we need to see where exactly did it hit and how many points do we give to the user. Okay, so now to find the hits, we are going to create a new file. We are going to right click and we will create a new file and we are going to call it path picker. So we are going to pick the path from this. So we are going to import CV2 and then we will import numpy as np and then we will import pickle. So what exactly are we trying to do? We will take in this image that we saved of the image board. Oh, that is bad. So first of all, let's just go back and take the image of the board. So we will write here CV2 and we will run that and we will stop. So if we look at the image board, now it's fine. So that's good. So I will remove that from here so that I don't accidentally overwrite it again. So we need to bring in this image of the image board and we need to get these points. Now you can open up it in Paint and then you can find the X, Y location of each one of these and then you can put it in a text file and then you can import it into the main file, which is a long process to be honest. So what we will do instead, we are going to write a script which will be, it's not complicated, but it is a little bit technical. We will write that down and based on that, we will just click the points and we are going to save the location of the polygons. Even if we add like 10 points to that polygon, it is fine. You can add 3 points, 4 points, 10 points, 20 points, whatever amount you want, you can add. And then we are also going to store the number of points. So here the score should be 5, here it should be 60, here it should be 10, here it should be nothing. So we need to give each of these categories a score. The nothings we can ignore, but the rest of them we have to give points. So we will create a new file with this and that will allow us to easily annotate all of this. So it will be quite easy to work with. So what we will write down here, first of all, we are going to create two lists. We are going to first of all call it polygons. This will be our first list. In this, we will have all the polygons. So we will have all the polygons, and not just the polygons, we will also have the points, all the polygons and their points. So 5 points, 10 points, whatever it is. And each polygon can have 1 point, can have 2 points, 3 points, 5 points, whatever number of points we have. So no, each one should have at least 3 points. So then we have the path. The path is basically one polygon. So the path of one polygon. So we will write it down one by one, and then we are going to put it all together as one polygon. So here, first of all, we will write image is equals to cv2.imread, and then we are going to write image board board dot png, and then we are going to write do we need to write anything else? No, we don't need to write anything else. Okay, so once that is done, what we will do is we will create a while loop, because we are clicking on points. Even if we have just one image, we need to loop so that we can add different points. So what we will do here is we will write cv2.imshow, and we want to show the image, and we will call it as img. And then we are going to write here that cv2.wait key is 1. So it will keep running. So let's go ahead and run this. This should give us a window. There you go. So this is our image, and we can click on it and it is running. Even if we close it, it will not close because it is running a while loop. So that is good. So we can close this, and now what we will do is we are going to click on the points, and we are going to save their location. So to do that, what we have to do, we have to create, should we do that first, or let's write it down here. So we are going to write cv2.setMouse callback, and then we are going to write image. This has to be exactly the same. This is the name of the window. And what do we do when we detect a click? We call a function. We will call it mouse points. And this mouse points we are going to define here. And what we will do is we will get the events and the X and Y and the flags and the parameters. So we don't need to use all of these, but this is what is the requirement. So we will write here if our events is equals to cv2.event underscore left button down. So if we detect a left button click, then we are going to append to our path. So path dot append, and we are going to append X and Y. So this is basically the X and Y position of the mouse click. Append X and Y. So that is good, but then we don't know if it actually clicked or not. Actually, we can print it out and we can see. So here, if I write path, so we can write print path, and if I run this and if I click, you can see it saves. So path was 1 point, and then second point, then third point, fourth point, and so on. But visually it's not appealing because we don't know where we clicked. So what we can do is we can loop through all the points and we can draw them. So we'll write here 4 point in path. We will write cv2.circle, and we will put it on our original image. We will put in the points. We will give it a thickness, a radius, and then we will give it a color, let's say red. and we will give it cv2 dot fill. We want it filled. So let's run that, and now wherever we click, it is going to fill up with that red color. So that is perfect, and it will what do you call, add to our path, but it still doesn't look like a complete path. So what we can do is we can take these points and we can create a polygon from it. So to use this, we have the function called cv2 dot poly lines, and we need to send in our image, and then we need to send in the points for all the points of all our polygon. So that is basically our path at this point. So we are simply sending in the path, and then we are saying that it is closed, so we will write true, and then we will give in the color. So let's say green 255, or let's say blue 0, and then we will give in the thickness, which is 2. But the issue here is that it does not accept it as a list. So this here is a simple list, a Python list. It does not accept, this function does not accept Python list. What is it accepts is a NumPy array. That's why we imported this NumPy. So why do we do that? Because it is the requirement of the function. Otherwise we would ignore. So let's say we write here our points is equals to numpy dot array, and then we will give in our path which we want to convert, and what we want to convert it into is numpy dot integer 32. And not only this, but it also has to be reshaped. It means it has to have some brackets here and there. So we can write here dot reshape. Again, this is just a requirement. We will write here -1, 1, and 2. So whenever you're drawing polygons from a list, you have to do this. End of story. So not a pretty story, but still, that's the idea. I think I pressed the wrong button. We need to format this. There you go. Okay, so now we will be able to see. So we are basically putting the polygon and we are putting it back on our image. So if I click on this, oh, what happened? Oh yeah, one more thing. You have to add another bracket here. Another bracket here, and you have to write BTS, the points in here. Yeah, this is the requirement. So if I click now, and if I click on this, there you go. Now you can see a line. If I click on that, and then I click on it. Blue might not be the best color. So let's just change it to green. So I click on this, and then this, and this, and this. Don't worry about the line in between, that's fine. But that's the idea. So now what we need to do is, whenever we have our points, so you can have more points than this. So for example, if I'm doing the one above 5, so I can have multiple points like this, and that's fine. So I can do it like that. That's fine as well. But the thing is that we need to save this as a polygon, and then we need to add another polygon. So basically, whenever we are done with the polygon, we should press a button and it should save that polygon, and then we go to the next one and we draw that, and then to the next and to the next. So how can we do that? It's very simple. It's not complicated at all. What we will do is, instead of writing cv2.wait key 1, we are simply we are giving it to a variable. We will write here key is equals to this, and we will say that if key is equals to ORD and we have pressed the Q button, then we are going to save this path into one big polygon. Okay, so here what we will do, first of all, we will ask the user to give in the points. So points is equals to, or let's call it score. Score is equals to integer, and we will ask for an input, and in the input we will write enter score. So yeah, that is our score. Then we will append it to our main list, which was polygons. This will have all polygons. This is a single polygon. So we can write here current single polygon. Okay, so this is a single polygon, and this is, when we are done with this, we put this inside polygons. So here we are going to write polygons dot append, but we don't want to append only this path. We want to append the path and the score. We want to do both of them so that later on we can import it and know which polygon has how much score. And to see if we are in the right or heading in the right direction, we can write here print. We can print total polygons, and we will write here the length of polygons, not the platform, polygons. There you go. So that will give us the length of the polygons, and then we need to delete the path because we need to restart for a new polygon. So whenever we do that, we need to reset the path again. So that is good. So every time we do this, let's run it. So if we create one of them, and if I press the Q button, it will ask me enter the score. I will write 5, let's say, and it will tell me total polygons is 1. Then I can do another one. I can press Q, it will ask me the score. I will say 10, and now total polygons is 2. But then we need to save it in a file so that we can import it to our main file here. So what we will do here is that we will write if our key is equals to ORD, and we are going to write that if it is, we will give it a key that is far away so that we don't mix these buttons. You can keep them close like Q and W, but I like to keep it far away so that they don't mix up. So I will write the furthest, which is P. And once we do that, then we need to do with open. We are going to save our file by the name polygons, and we will give it the permission for writing, and we will write WB, and then we are going to, where are the quotations? Okay, we write as F as a file, and then we are going to print the polygons before we send it, polygons, and then here we are going to write pickle.dump, and we are going to write polygons, and we will write our file name. So this is our file, and that is it. So here then we can simply break. So we need to finish our loop. So I believe we have written pretty much everything we require. So let's go ahead and try for 1 or 2, and then we will do it for the whole. We need to import that there and test it before we can do for the whole thing. So let's say we will do it for this one. Actually, which of these are we hitting? Let's go here. So we are hitting this one and this one here, but that one is not detected. So let's change the video. Let's go here and choose video number 2. So we are hitting, no, this one didn't detect. This one, and this one, and this one. So let's just do these two on the sides, and then we will do the rest of them later on. So let's run that, and we will do this one. Now I will press Q, and it will ask me for the score. I will say 60, and I will press enter. Total polygons is 1. Then I will do this one. I will press Q. It will again ask, score is 60. I will press enter, and then I will go back. I will click on the top here, and then I will press P. So now it is showing me, before it saves, it is showing me this list. So this is one element and this is the second element. So now what we need to do is we need to import this in our main file, and if one of them or two of them right now are importing properly, then it means the rest of them will import properly, so we can come back and do for the whole thing. So for testing we can just do one or two and then we will do the rest of it. So here what we will do is we will write with open, and by the way it's saved the file here called polygons. You can see here this is the one that has this information. Okay, so let's go here and we will write with open, and we will write polygons, and we will write RB for the axis, and then we are going to write as F, and then we will write polygons with score is equals to pickle dot load, and we will load in F. And here we can write the length of our polygons, polygons with score, just to make sure that we are heading in the right direction. We should have two elements here. So let's run this, let's run the main, and there you go, we have two elements. So this means it is imported fine. We can even import, we can even display this. Actually, we should not delete that. Let's keep the length, the print. Yeah. So we can print it out to see if we are getting the same thing. Yes. So here you can see we are pretty much getting the same thing from our file polygons. If you open it up, you will not understand anything. So here you can see this is the data that we are getting from this file polygons, and it is exported properly from here and it is imported properly over here. So that is good news. So now what we can do is we can check where exactly are these points, and we need to check if our ball detected is hit within these polygons. So it might seem confusing, but it is not. It is very simple to do. So how can we do that? So after we detect the contours and we have found the hits, once we find the hits, we are going to check if this hit is in one of the polygons or not. So we will write here for poly in polygons with points with score, we are going to get our poly, and what we will do is we are going to check whether it is inside our polygon or not. To check this, first of all, we need the center point of the contour that was found. So the contour found is here. So we will write here contour found, and we will get the first element. There might be multiple contours, which in case is not very relevant at this point, but it will get the biggest contour in the first location. This is by default what find contour function in CV zone does, not in OpenCV. In CV zone it sorts out the biggest one at first. So we will put it at 0 here, and then we will write here center. We want the center information of our contour, and we will store it in center. So that is good. We have the points which we want to check. Now we need the polygon in which we want to check if this point is inside it or not. So to do that, again, we have the polygon, but we need to convert it. So we will write here that our polygon, let's call it P, is equals to numpy.array, and our polygon is basically coming from here. So let's say poly score. Okay, let's say poly score, and then we can write here that this is our poly, this is our polygon, and we are getting it from our poly score at 0, which means this is the first element. So if you remember, when we are dumping it, we are putting the path, which is the polygon, and then we are putting the score. So the first element is the path, the second element is the score. We need the first element now, which is basically our path. So that's why we are writing 0 here. And once we write 0 here, then again, as you know, we have to convert it, and we need to make sure that it is numpy.int 32. So that is basically, why is it giving an error? Oh, I removed one of them. That's bad. Okay. So now our polygon is ready, and now our center is ready. Now we need to check whether this point is inside this polygon. So how can we do that? We can write here cv2 dot points polygon test, and we will give in our polygon, and then we will give in the center points, and we will write here false. So this will check if this center point is within this polygon, and we will call it inside. So it will give us yes or no, true or false. So what we can do is we can print inside. Okay, so let's run that. Let's see what happens here. Which video is this? There you go. 1 means inside, -1 means outside. Hit detected. 1 means inside, -1 outside. So it's doing that again and again. So that's good. It means we are detecting the hits, and we know that this polygon is inside this ball is inside this polygon. So once that is done, what we need to do is, if it is inside, we need to do a few things. First of all, we are going to save the location of the ball hit. Then we are going to save the location of the center point, and then we are going to save the location of the polygon. When we have all these three stored in a list, later on we will draw them. We should not draw them only when we detect the hit. We should draw them all the time. Even after the hit, we need to draw them. So we cannot draw them inside this if statement. We need to draw it outside this if statement. So we need to store all these values inside here so that we can later on draw it continuously. I hope that is understood. So here we will write if inside, we can remove this. 1 means true, so we don't need to write equals to 1 or something like that. So we will create a new list, and what should we call it? We will call it draw ball, or let's say hit draw ball info list. So once the ball is hit, the drawing information will be inside here, so we can draw again and again. So inside this list, we are going to append 3 things. We are going to append the contour found at 0. We want to append the bounding box information so that we can draw the bounding box. Then we need to append, where is that? Yeah, this one here. Okay. So then we need to append the center point, so we can draw the center point as well. So we can write here center, or we can just write this center here. It's the same thing. And then we need to add our poly, so we can draw the polygon itself later on. So these are the 3 things that we have now. And now what we will do is we will draw it on our polygon, on our image. Now before we go out of this loop, the last thing we will do is we will increase the points. So whenever we detect the hit, we need to increase the points whenever it is inside. So what we will do is we will say that our total points, or let's say total score, plus equals poly score at 1. So if you remember, this is element number 0, this is element number 1. So we are getting this element from the list, poly score. This is the poly score. Where is it? This is the poly score from polygons with score. So total score we did not define. I think we named it something else. Did we name it? No, we didn't. So we will write here total score is equals to 0. So we will go down here, and now what we can do is we can print the total score. Total score prints total score. So let's run that. The total score is 0. When it gets a hit, let's wait for the hit. There you go. 1. So there were 2 hits and 3 hits, 4 hits. So every time it is adding 60. So that is the basic idea. So let's go ahead, and what else can we do? Yeah, we need to draw now. So pretty much everything is working at the back end, but what we haven't done is we haven't drawn. So what we can do is we can directly draw on our image. So what we will say is for, let's say, what was the first one? Bounding box. So bounding box, then the second one was center, and the third one was poly. In what was the name? Hit draw ball info list. These are the 3 things we are getting from this list, and then we are going to draw them. So cv2 dot rectangle, and what do we need to input? We will put it on the image contours, and then we will give in our location, which is the bounding box, and then we will give in the color. Let's make it purple, 2550-255, and then we will put it at 2, the thickness. And then we will draw the circle, cv2 dot circle, and we will give it to image contours, and we will write in the center. This is the center position. The radius, let's put it as 5, and the color, let's put it as green, 2550, and we want it filled, so cv2 dot filled. That's the idea. And then we are going to write cv2 dot draw contours, and then we are going to draw it on our image contours, and then we will give in our polygon, which is poly, and then we will draw all the polygons. So we will write -1, and then we will write color is equals to 02550 green, and then the thickness will be cv2 dot filled. So this is how it should work. So let's run it, and we will open up image contours. This is the main image. So let's wait for the hits. This is the first, this is the first hit. This is the second hit, and this is the third hit. The third hit, it didn't go in here, it is on 5. That's why it didn't draw. Otherwise it would have drawn here. Why are there so many windows? We need to do damage control. Let's even the original image we don't want the mask image. We just want image contours at this point. And we were outputting an image here, and then we were outputting in a loop somewhere. Yeah, this one. Let's remove that. Yeah, now it is one clean image. So hits didn't work. Let's do it to the other one. So let's go and do it to video number 3. Let's try that. There you go. It hits and it is drawing here. Why is it drawing here? So something is wrong because it's not in that area. Then why is it showing that? Okay, so let's go and check out what the issue is. So if it is inside, then this is, are we printing out the score? No. Okay, if it is inside, then we are appending the bounding box info, the center and the poly. Yeah, that's fine. And then based on that, we are drawing each of these every iteration. Yeah, that seems fine to me. Do we need to reset something? Not really. Hit is 0 is already resetting. So we are already resetting the hits. Maybe it's not going inside. We need to print this out. Or let's print out the score if it's actually detected. Print score. What is it's called total score. Yeah. So total score is 120. How is that 120? This is detecting wrong because it's inside here and it's not. Okay, let's just remove this part and let's see. Okay. So it is hitting, but the issue is that it is thinking that it's inside when it's not. So here we need to print, or before that we need to print inside. Print inside. Oh, we are printing so many things. We need to remove all the prints so that we can see what is happening. There's another print somewhere. Print with this. Let's remove all of them. This is the one that we want. Yeah, let's run that. -1. -1. So it is -1. Is it reaching inside this? Print. Print. Yes. Oh, it is reaching. Even though it is -1. So we need to put here equals to 1. Let's see if that works. Yeah, now it works. So even if it is hitting, it's not saving that location. So that's good. So which one were we using? Video 2? Video 2. Let's run that. Yeah. So now if it hits, it detects and it colors that part. It didn't hit here, so it didn't detect. And now I believe the numbering, the scoring will be correct as well. So if we go and print the total score, then we can see what do we get. So right now it's 0. So you can see even if it falls down, it doesn't detect it as a hit. Okay, so this numbering is wrong. It is detecting 60 is 120. Why? Maybe it's detecting as a double hit. So what we need to do, if it's detecting as a double, so it's going fine from 120 to 180, but 60 to 120 was too fast. So maybe we need to increase this to 10. So yeah, 60 and then 120. Perfect. That was the issue. It was detecting multiple times. Okay, so what we can do now is we can actually, now the thing is it doesn't look good. When it hits, it's fine, but covering the whole thing up, it doesn't look that nice. So what we can do is we can keep it transparent so that people can see the back as well. And you might think that it is quite difficult, but it's actually fairly simple. All we have to do, we have to create a blank image. Image blank is equals to numpy dot zeros, and we will give in the shape of our image contours. Image contours dot shape at 0, and then image contours dot shape at 1. So we are basically creating a matrix of zeros of the same size of our image contours, and it is 3 channels RGB, so we have to give in 3, and it is unsigned 8-bit, which means 0 to 255, so we have to mention that as well. So unsigned integer 8 bits. So this blank image we are going to draw on this blank image. So we will copy this, and instead of drawing other places, we are going to draw on this. So no, actually not this, the draw contours, the polygons, we want to draw on that. And once we do that, we are going to do an added overweight, not overweight, added weighted, add weighted. So we will write here cv2 dot add weighted, and we are going to weight in our image contours, or is it image contours? Yeah, image contours, or let's use image board, and then we will use 0.7, and image blank, this will be 0.5, and then we have 0, the gamma. If you did not understand, I will explain now. Image contours is equals to this, or should it be image board? Yeah, it should be image board. Let's make it image board, and we can output image board as well, image board, and we can actually stack them together as well. Let's just run this now, and there you go. There you go. So now it doesn't actually, it overlays on it, it doesn't actually remove it. And here on the side, oh, we need to open this again, the frame counter. So on the side you can see that it shows the hits and the ball detected and the center here. There you go. And then here it shows which place did it detect. So that's pretty cool. And the points, we can display the points up somewhere here. So we can actually stack these images as well. At the end we can stack them here. So what we can do is we can write here image stack is equals to cv zone dot stack images, and we give in image contours, and we give in image board, and we want 2 columns, and we want the scale to be 1. So we can just show image stack instead of showing 2 different images. So if you run that, now it is a single image. It looks better and it's easier to handle. So yeah, there you go. That is looking pretty good. And yeah, so it didn't detect the one above because it is not in the correct region, because we have only done for this 60, this 60, and this 60. Now we can go back and do for all of them, and then we can return to this and see if it works or not. So we will go to path picker, and here we are going to run it. Now this will take some time, so you can do it by yourself or you can watch me do this here. So let's go ahead and label these. So first of all, we will start with 5. So you don't have to be very precise. You can just press Q and it will ask for the score. That is 5. Then we will go to the next one. So this is going to take a while, but not as long as if you had to do it manually through what do you call paint and then write down all the values. That will be a really painful process. So, well, this is painful as well, but not as painful as that. So, but make sure you don't make any major mistakes here. Otherwise, you have to repeat the whole thing. So that is 10, and then here is 5. Q and 5. Yeah, so don't add this. This is empty. So we can put it here. If you add it by mistake, just write 0 as the value. This one is 5. Then this one is 10. So this can be used in other projects as well. If you have a different kind of a dartboard or if you have a different game, this can be used for many other projects for marking. So hopefully this will help you in other projects. So we have done one of them. So we are not going to stop. We are going to continue with the same, and we will write it down here 60. So we will keep going in and in, but right now we are doing 60s. Again, I'm not trying to be very accurate. Then we will do 60 here again. So don't forget to press enter after you write in the value. 60. So 60s are done. Now we are heading to 80s. 80. 80. This is the last 80 we have. And the last one is 100. So we have a few of the edges. So we will select those, and there you go. We'll put that in and we'll write 100. And now is the main part. We click on the top and then we click on P to save. And there you go. So we stored 20 polygons and each of them has their scores. Okay, so now we can go to our main file and we can simply run, and hopefully everything is already there and it will work perfectly. Let's hope for that. So the first hit 60, that's good. Second hit 60, third hit 5. Excellent, I love it. So what we need to do now is actually to write down the score because the score is not visible. So that part is actually fairly simple. Where should we write the score? Should we write it on the contours or the image board? I think on the contours because that is the place where we are doing the highlight as well. So let's put it on image contours. So here we are going to write. So now we are going to use the CV zone put text rect. So normal text will just have a text and nothing at the background, but with CV zone put text rect, there will be a rectangle at the back of the text, so it will be easier to read. So we will write here CV zone dot put text rect. We will give in our image contours. We want to draw on that, and then we will write an F string. So we will write total points, and we will give in our point values. So total, actually let's call it score. I'm always mixing those up. Score, total score. And then we are going to give in the position. Let's give it 10 and 40, and then we will give it a scale. The scale is equals to 2, and the offsets, let's give it as 20. You don't have to give in all these values. It's just that this will look a little bit better. You can also change their colors, but I'm not going to do it right now, but if you wanted to, you could. And again, you have to store it back into image contours, not contours, we are doing it on the board. So image board, yeah, wait, which one is the, yeah, we are doing it on image board. BOARD is equals to this, and this should be image board as well. Let's push this down so we can see. Yeah, so let's go ahead and run it, and hopefully this time, oh, there's an error. Yep, there is an error. Bad arguments. What happened there? Did I miss a bracket or something here? Image board and image board. Let's try it again. Yeah, still the same problem. So if I remove this line, oh, if I remove this line, does it work? Yeah, it works. So that line is called, oh yeah, I remember now. Yeah, I forgot. So basically, this just does not output one image. It outputs an image and the location of the bounding box. So we don't need the location of the bounding box, so we can ignore that by writing underscore. And there you go. Wait, why is it giving it on that? It should be on the board. Oh yeah, that is the board. Yeah, my bad. That is the board. Okay, so let's run that. But let's do it after the weighting, because otherwise the colors, they get dull, so we don't want that. Let's do it after that. Yeah, there you go. Total score 0, and 1 2 3 go. 60, excellent. 120, excellent. 125, excellent. I love it. So this is basically, and now it's repeating, so it will keep adding the score, which, well, it would not make any sense, but that's the idea. So here you can see the center points where they are drawn, and this is the location of the hit. So let's try out the other video. Where is video number 3? Let's try that. 5, it didn't detect the 5. Ooh, that didn't detect. So the reason it's not detecting these two is because if you look at the center of this, it is outside, it is on the black line, this black line. So that's why it is not detecting that. So it is outside that. So it's not detecting this part. This part is not detected because it is in the red zone, which has no points. This part is detected because it lies, the center, if you see this green point, lies within this 60 region. So that's why it is detecting 5. So I would say that is a win-win situation. I really like this video, the second one. It shows that when it hits and drops, it doesn't detect it. And then when you hit it on one side, it detects it, the other one detects it, and the upper one detects it as well. So this was basically our project for today. It was a fun game that we created using basic image processing techniques, and what we did at the end is counted the score, where did the ball hit, and what was the actual score. So this is it for today's video. I hope you have learned something new. If you did, Don't forget to like and share and subscribe, and I will see you in the next one.